Have you ever pulled up next to a liquid tanker truck on the highway and just stared at that massive silver cylinder rolling down the road and thought, why is it round? Why not square? Why not rectangular? Why not just a giant box like every other trailer out there? It seems like such an obvious question, but almost nobody ever asks it. And the answer involves physics, safety, fluid dynamics, and some engineering decisions that go all the way back to the early days of industrial transport. Stick around because this one is going to be a surprise. Hi, my name is Jeremy and this is Trucks United. What even is a liquid tanker truck? Before we get into the shape itself, let us make sure we are all on the same page about what a liquid tanker truck actually is. Simply put, it is a truck pulling a large enclosed vessel designed to transport liquid cargo in bulk. And when we say liquid, we mean everything. Gasoline, milk, liquid chocolate. Yes, that is a real job. Chemical solvents, acids, liquid fertilizer, and even liquid oxygen, carried at cryogenic temperatures. Each of these liquids has completely different properties. Some are corrosive. Some are flammable. Some need specific temperatures. And yet, almost all of the tanks that carry them share one thing in common. They are round. Tanker trucks have existed for over 100 years, and engineers were building cylindrical tanks right from the start. So why that shape? Let us get into it. The physics of pressure, why shape matters. This is where things get really interesting, and I promise this is not going to turn into a physics lecture. Well, maybe a little bit, but bear with me because once you understand this, you will never look at a tanker truck the same way again. When you fill a large container with liquid, that liquid exerts pressure on every single surface it touches. This is called hydrostatic pressure, and it pushes outward in every direction. The walls of the tank have to be strong enough to contain that pressure without deforming, cracking, or failing catastrophically. And nobody wants a tanker full of gasoline failing catastrophically on the highway. Nobody. Now here is the key question. Which shape handles outward pressure the most efficiently? The answer is a cylinder. More specifically, a cylinder with a circular cross-section. Think about it this way. When pressure pushes outward on a curved surface, the force is distributed evenly across the entire surface of that curve. The pressure does not build up in any one spot. It gets spread around the whole wall of the tank, traveling through the material as what engineers call hoop stress or circumferential stress. The wall essentially handles the load by being in tension, pulling against itself in a continuous loop all the way around. This is actually the same principle behind why pipes are round, why pressure cookers are round, why submarines are essentially giant cylinders, and why the pressure vessels in nuclear power plants are round. It is one of the most well-established principles in structural engineering. A circle is the most efficient shape for containing internal pressure. Now compare that to a flat wall. When pressure hits a flat wall, it creates bending stress right at the center of that surface. The wall wants to bow outward, and the corners where flat walls meet are even worse. Stress concentrates at those points, like a magnifying glass concentrating sunlight. Engineers actually have a term for this, and we will talk about it in detail in just a moment. The round tank handles pressure with elegance. The square tank fights against it. And when you are building something that has to survive millions of kilometers on rough roads carrying tens of thousands of liters of liquid, elegance is not just a nice to have, it is an absolute requirement. Okay, so we have covered pressure. But there is another problem that liquid tankers have to deal with that most people never think about, and it is the liquid moving around inside the tank while the truck is driving. This is called surge and slosh. It is genuinely one of the most dangerous characteristics of liquid cargo transport. Imagine braking hard at highway speed. The liquid inside the tank does not stop when the truck stops. It surges forward toward the front of the tank. That surge can be so powerful that it actually pushes the truck forward, making it significantly harder to stop. On a fully loaded tanker carrying 30,000 liters of fuel, we are talking about a wave of liquid that can exert enormous force on the front wall of the tank. When the truck comes to a stop, the liquid sloshes back the other way. It keeps oscillating back and forth, creating what engineers call dynamic loading. This wave motion can set up a resonance where the liquid starts sloshing in sync with the truck's movements, and the forces can multiply. This is a genuine safety concern, and it has contributed to real accidents over the years. Now here is where the circular cross-section helps again. A round tank has no corners, no edges, no flat walls for the liquid to slam against with full force. The curved walls redirect the energy of the moving liquid more smoothly, dispersing it around the curve, rather than taking a direct impact. It is a bit like the difference between running straight into a wall versus running into a curved ramp. One stops you dead, the other redirects you. Tanker engineers also use baffles inside the tank. Baffles are internal dividers with holes in them that slow the movement of liquid from one section of the tank to another. The round shape of the tank itself is the first line of defense against the slosh problem, and it works remarkably well. Strength without the weight. Here is something that surprises a lot of people. One of the biggest advantages of a round tank is not just that it is strong, it is that it achieves that strength while using less material than any other shape would require. Remember how we said a circular cross-section distributes stress evenly? Well, that even distribution means that every single part of the tank wall is doing useful work all the time. There are no weak spots that need extra reinforcement. There are no corners that need to be thickened up. The entire wall contributes equally to holding the tank together. What this means in practice is that engineers can build a tank that is strong enough to handle the job using thinner walls than they would need if the tank were any other shape. Thinner walls mean less metal. Less metal means a lighter tank. And a lighter tank means the truck can legally carry more cargo per trip. In the trucking industry, payload is everything. Remember from our previous videos how European trucks have to stay within strict length and weight limits. Well, weight limits apply to tankers too, and every kilogram you shave off the weight of the tank itself is another kilogram of cargo you can legally haul. Over the course of thousands of trips, that adds up to a genuinely significant amount of money. Aluminum is the most common material used for tanker construction today, and a modern aluminum tanker shell can be surprisingly thin considering the loads it handles. That is not a miracle of material science. That is geometry doing the heavy lifting, literally. Why not square? The math nobody talks about. So, now that we know why round works so well, let's talk about why square would be such a disaster. I think this really drives the point home when engineers design pressure vessels and structural containers. One of the things they calculate very carefully is stress concentration. This is the phenomenon where stress in a material does not distribute evenly, but instead bunches up at certain points. The worst places for stress concentration are sharp corners and edges. Think about what happens when you want to tear open a packet of sugar or a bag of chips. You do not just pull at the flat middle of the bag. You look for a notch or a corner, because that is where the material is weakest and where it will tear most easily. That is stress concentration working in your favor as a hungry person. But it is absolutely catastrophic when you are designing a tank to hold tens of thousands of liters of fuel at speed on a bumpy road. A square tank would have 4 corners along its entire length, every single one of them acting as a stress concentration point. Every bump in the road, every surge of liquid, every pressure change inside the tank would send stress racing toward those corners. The material there would fatigue much faster than the rest of the tank. Fatigue cracks in a fuel tanker are about as welcome as a screen door on a submarine. Engineers figured this out a very long time ago. It is not that nobody ever tried to build non-round tanks. It is that the physics made the problems obvious very quickly. The round shape is not a convention or a tradition. Cleaning and hygiene, the hidden reason. Now here is one that most people never think about. Honestly, when I first came across this, I thought it was a bit of an afterthought. But the more I looked into it, the more I realized it is actually a really significant factor for certain types of tankers. Think about a tanker that carries milk, or liquid chocolate, or fruit juice, or any food-grade liquid. After every delivery, that tank needs to be thoroughly cleaned and sanitized before it can be used again. And the inside of a large metal tank is not exactly easy to clean. A round interior with no corners and no flat edges is dramatically easier to clean than any other shape. Cleaning systems inside tankers work by spraying pressurized liquid in a rotating pattern from the inside of the tank. This is called a clean-in-place system, often abbreviated as CIP. The rotating spray hits every surface of the tank, and the liquid drains out completely because the curved floor channels it naturally toward the drain point. Now imagine trying to do that in a square tank. Every corner would be a trap for residue. Every flat wall junction would create a dead zone where the spray does not reach effectively. You would need far more complex cleaning systems, more water, more cleaning chemicals, more time, and you still might not get into every corner properly. For food safety, that is unacceptable. For chemical tankers where cross-contamination between loads could be dangerous, it is even less acceptable. The round shape makes the cleaning process simple, effective, and fast. In an industry where turnaround time is money, fast cleaning is not a small thing. Now let's talk about regulations, because as we have seen in other videos about European and American trucks, the rules surrounding commercial vehicles shape everything about how they are designed and built. Tanker trucks are subject to some of the most detailed and specific regulations in the entire trucking industry. And this makes sense when you think about what they are carrying. A tanker full of gasoline, sulfuric acid, or liquid nitrogen is essentially a rolling hazard that needs to be managed extremely carefully. In the United States, the Department of Transportation, known as DOT, has a whole series of specifications that define exactly how different types of tankers must be constructed. Those specifications cover wall thickness, material grades, weld quality, pressure ratings, valve types, and yes, the shape of the tank itself. The rules for cylindrical tanks have been refined over decades based on real-world experience, including accidents and failures. In Europe, similar standards are governed by the ADR Agreement, the European Agreement for the International Carriage of Dangerous Goods by Road. It covers everything from tank construction to the training required for drivers. The regulations did not invent the round shape. Engineers got there first. But the rules do codify that preference and enforce it, and they set minimum standards for wall thickness and pressure resistance that are specifically calibrated for cylindrical designs. If you tried to build a square tanker and meet those same safety standards, you would end up with something so thick-walled and heavy that it would be practically useless as a commercial vehicle. Are all tankers round? The exceptions. Okay. So now that I have spent the last several chapters explaining why tankers are round, let me complicate things slightly. Not all tankers are perfectly round, and understanding the exceptions actually reinforces why the round design is so dominant. The most common variation you will see is the elliptical cross-section. Instead of a perfect circle, the tank is slightly flattened, wider than it is tall. You see this a lot on fuel tankers and some chemical tankers. The reason for this is simple. A perfectly circular tank sitting on a trailer sits quite high off the ground, which raises the center of gravity of the whole vehicle. A lower center of gravity is better for stability, especially when you are navigating corners with 30,000 liters of liquid sloshing around inside. The elliptical shape is a compromise. It keeps most of the structural benefits of a curved cross-section while lowering the center of gravity by being wider and less tall. It is not quite as structurally efficient as a perfect circle, but it is close enough, and the stability benefit on the road is worth it. Then there are multi-compartment tankers. These are tanks divided internally into separate sections, each of which can carry a different product. A fuel tanker delivering to a gas station might carry regular gasoline in one compartment, premium in another, and diesel in a third. Each individual compartment is still essentially a curved vessel. The divisions between them are carefully engineered to maintain structural integrity. There are also cryogenic tankers which carry liquefied gases at extremely cold temperatures, sometimes below -150 degrees Celsius. These tanks are double-walled with a vacuum between the inner and outer walls for insulation, similar in principle to a giant thermos flask. And yes, they are round too, so the exceptions are really just variations on the theme. The core principle, the curved cross-section that distributes stress evenly and resists both pressure and slosh, remains constant across essentially all of them. The future of tanker design. So where does tanker design go from here? Trucking is changing fast. Electric trucks are coming, new materials are being developed, and there is constant pressure to reduce weight, improve safety, and lower emissions across the whole industry. Change is driving many of the design priorities. On the materials side, composites are starting to appear in tanker construction. Fiber-reinforced plastics and carbon fiber composites can offer impressive strength to weight ratios compared to traditional aluminum or steel. Some specialized tankers, particularly in the food and chemical industries, are already using composite materials for certain components. The structural principles that make a round cross-section optimal do not change just because you swap out the material. So, the shape is not going anywhere. But the walls could potentially get even thinner and lighter as better materials become available. On the electrification side, the situation for tankers is even more complicated than it is for regular freight trucks. A loaded fuel tanker can weigh over 40,000 kilograms. The energy required to move that kind of weight over long distances, and then add the weight of a large battery pack on top, creates real challenges. The physics are not impossible, but the economics and the infrastructure are a long way from being solved. Electrification presents real trade-offs. And just like we discussed in our video about Australian road trains, imagining a charging network capable of supporting heavy tankers across remote industrial regions is a stretch right now. We think it is going to be a very long time before the diesel engine disappears from tanker transport entirely. Charging remains a major obstacle, but the round tank, that is staying. The physics that made it the right answer in 1910 are exactly the same physics that make it the right answer today. So let's bring it all together. The reason liquid tanker trucks are always round comes down to several things working together. A circular cross-section is the most efficient shape for containing internal pressure. It distributes stress evenly across the entire wall with no weak spots. It handles the surge and slosh of moving liquid better than any flat-walled design. It achieves all of this while using less material than other shapes, which saves weight and increases payload. It is easier to clean, which matters enormously for food and chemical tankers. And it is backed up and enforced by decades of safety regulations built on hard-won real-world experience. It is one of those engineering solutions where everything points in the same direction. The physics, the safety requirements, the economics, and the practicalities all arrive at the same answer. Round is correct. So next time you pull up next to one of those giant silver cylinders on the highway, you can appreciate that you are looking at one of the most elegantly solved engineering problems in the entire transport industry. Not bad for something that just looks like a really big thermos. That is everything for today. If you enjoyed this video, make sure you hit subscribe because we have a lot more trucking content coming. And trust me, there is a lot more to these trucks than most people ever think about. Thanks for watching, and we will see you in the next one.